So in this star delta conversion problem, they are asking us to find out the equivalent resistance between the terminals AB. Everybody should understand when I'm asked to find out the equivalent resistance, okay, equivalent resistance can only be found out across two terminals. Without the two terminals given, we cannot say what is the equivalent resistance. For example, if I give you a delta network like this, and if I ask you to find out, suppose this is 1 ohm and 1 ohm, okay, or let's say this is 1, this is 2, and this is 3, or let's do this also as 2 ohms, okay, and this is A, B, C. Suppose if I ask you to find out the equivalent resistance of the circuit, find out the equivalent resistance of the circuit I'm saying, okay, if it is so, where exactly you'll find out the circuit resistance? See, we should not say find out the equivalent resistance of the circuit, we should rather be saying find out the equivalent resistance across some two terminals. You can find out the equivalent resistance across AC, or across AB, or across BC. Understand that? So always when you're asked to find out the equivalent resistance across which terminals, we have to find out, that is very important. So when they say across some two terminals, suppose they say find RAB, they'll say here, okay, across these two terminals they'll ask us to find out the resistance. So this is AB, okay, and the resistance is RAB. What is RAB? Then we can say RAB is 1 ohm, 1 ohm in parallel with 2 plus 2, something like that. Understand? So it all depends on which two terminals they are asking us to find out the equivalent resistance. That is one part. Fine. So now what they've asked us to find out is the resistance, equivalent resistance across the terminals AB. Fine. Now it's not only that, they also have very particularly told that you have to use star delta conversion. Another thing that I want to explain regarding star delta conversion is, when they say star delta conversion, it does not mean that you should only be converting star into delta. No. Okay, if you find a delta which can be converted into star, you can even convert delta into star or star into delta. Okay, the name says star delta conversion, does not mean that you should always search for a star and convert that into delta. No. Okay, star delta means it's star to delta or delta to star conversion. First thing that I want to clarify, it could be star being converted into delta, or it could even be a delta being converted into star. Is that okay? Now your job is to find out a delta or a star, okay, to find out RAB, the resistance across the terminals AB. So how to do that? When would be a conversion easy? When would be a conversion easy? When, suppose you find this is a delta. See, this is a delta. 6, 6, 18 is a delta. Fine. Then 5, 6, 18 is a star. 6, 6, 6 is a star. Then 6, 18, 18 is a star. Fine. 6, 6, and these two are in series. See, 18 and 6 are in series. So this series combination, then this and this is a delta combination, delta network. So there are so many stars and so many deltas. So which star to approach or which delta to approach for the problem given is what we need to think of. Okay, so always remember this. If there is a provision, of finding a star with all the resistance equal, for example, see, this is a star, right? This is a star. Fine. What is a star? Star looks like this. Everybody see here? This is a star. Out of star, we are trying to get a delta, or we can have a delta, or you can get a star out of that. And the lines need not be slant like this. They need not be these lines which are bent like this. They could even be straight lines, as I've been showing the one here. See, this is also a star. 6, 6, and a 6 is a star. Understand that? So we need to obtain. Let's consider this star and obtain a delta out of this. Everybody's okay with that? So see, what do I do? Everybody just don't write anything. Just observe here. Yeah. Just a minute. Yeah. Everybody observe. What I'm going to do now is I will draw the delta that I want to obtain from this dotted lines here, and another delta should come across these 2 points. So this is delta that I'm trying to obtain from 666 star. Okay. For namesake, I'll call them as R1, R2, R3. For namesake, I'm doing this. Everybody's understanding that? Okay. Let me yeah. Let's move on. Let's consider that 6, 6, and 6 star. Okay. So in the solution, let us say consider here. This is what I'm asking you to consider. There is a 6 here, 6 and 6. So what we are trying to obtain from this? We are trying to obtain a delta out of this. Okay. And deltas come with R1, R2, R3s, and star come with RA, RB, RCs. Let's remember that. Okay. Just for the reference, let me call this as R1, this as R2, and this as R3. So I need to obtain R1, R2, R3. What is R1, R2, R3? What is R1? Let me go back. You have to remember this equation. Yeah, see here. What is R1? See, R1 is this. Sum of the product of all the resistant pairs. Sum of the product of all resistant pairs, I'm saying, divided by the resistance. How? Which resistance is that? Suppose if you want R1 means, okay. So see which resistor is there perpendicular to this. Okay. So you need not have to write the equation here. You can directly write what is R1. Since all the resistors are same, I can write my R1 as, okay. I don't know which is RA, RB, RC here. Let me tell you. Okay. I don't know which is RA, RB, RC, but I know the resistance values. So it is, maybe it's RA into RB plus RB into RC plus RC into RA. There, I don't know which is RA and RB and RC. Okay. I just pick the resistor pairs. Okay. And take their product and add all those products. And in the denominator, what you will have? You will have 6 again. So this is R1. If this is R1, what is R2? R2 is also going to be the same. What is R3? R3 is also going to be the same. R1, R2, R3, all the three resistors that we are going to obtain now are going to be the same because all the resistors in that star is same. Everybody understand that? Okay. So R1 is what? If you do this, you will obtain your R1 equal to 18 ohms. And since all the resistors are same in that star, okay, I can say my R1 is equal to R2 and R2 is equal to R3, and that's equal to 18 ohms. So see here, in this place, in the place of 666, we will have this R1, R2, R3. So you can name them in dotted path. That's not given. R1, R2, R3 is not, it's something that we have marked. Okay. So therefore, after conversion, therefore, the network becomes. When do I call it as network or when do I call it as circuit? When there is a current flow with voltage connected, you can call that as circuit. When there is no voltage connected, no current flowing, you can call that as network. Understand what is the difference between a network and a circuit? Okay, so there should be some part of the circuit where there is no current flowing, so that we can call as network. Okay, but in circuit there is a path for current flow. There is no path for current flow. See, 5 ohms does not have a current flow. If you connect a voltage source, then you can have a current flow here. So to be precise, network is something which is incomplete. Circuit is something which is complete for the current flow. Understand? It's just that. Okay, so therefore the circuit would become what? Now from here on, how it is going to look like? Let me copy this. Let me copy this. Just see, since this is the first problem, I'm giving you this in this detail. Yeah, what happened now is this. Yeah, see here. Let me take the eraser. What I'm saying, what is not going to be there? So this 6 ohms will not be there. This 6 ohms will not be there. Okay, this 6 ohms will not be there because that is something that we have converted now. Everybody is okay with that? Then what would be there in that place? In that place, a star should come. How is that star looking like? See here? Across these 2 points, there should be R1. Across these 2 points, there should be R2. Let me mark those points. Okay, the points are visible here actually. Between these 2 points, R1. Okay, between these 2 points, R2, and these 2 points, R3. Okay, since all the resistors are same, so this will be a safe thing to do. If the resistors are different, then you need to be really careful. Okay, so this is how the network is going to look like after conversion. So what is that? These are all 18 ohms. 18, 18, and 18. Now see, the things look simple now. What way the things look simple? Earlier, there were no resistors in series, no resistors in parallel. Now see the simple thing, how beautifully they are arranged now. How beautifully the things have been arranged. Yeah. Now, see how these 18 and 18 are connected. This 18 and 18 are connected in parallel. How this 18 and 6 are connected? This 18 and 6 are connected in series. Okay, and that series combination is in parallel with this. So this is how we can go on reducing the uh, number of resistors by taking the equivalent resistances. Okay, so this implies this. Okay, so this 18 ohms will not vanish, it will be there as it is. Rather, what would happen is you'll have a resistor here which is 18 parallel 18. Understand? Then you will have a resistor here which is 18 plus 6 parallel 18. Why is that? See here, 18 and 6 are in series. So these two are in series, mind you. Okay, so 18 plus 6, that combination is in parallel with 18. So this is how we can write it. And this resistor is anyways 18 ohms. This is 18 ohms. Okay, this is 5 ohms. Now just find out these values. 18 parallel 18 is 9 ohms. And you can do this. This is 24 parallel 18 would give you what 18 parallel 24 would give 10.285. You can do it later. 10.285. So this is how the things look like. Now this 9 ohm and 10.285, how these two are connected? These two are connected in series. So what would this become? This would become this. This implies that anyways this 5 ohms we have, this 18 ohms is anyways going to be there. Okay, now you have this 9 ohms in series with 10.285. Okay, so it is 19.285 ohms. So this is 18 ohms and this is 5 ohms. So how would this reduce now? This would reduce into this 5 ohms is anyways going to be there. Now, what is this combination? What is this combination? This is 5 ohms. This is 18 parallel 19.285. So what would this be? I have calculated that. You can just take it down. That is going to be 9.31. Okay, and how this 9.31 and 5 ohms are connected? How they are connected? They are connected in series. Okay, so these are all terminals AB. We need to be good with that. So we have to write it because across AB they have asked us. So what is the resistance across AB now? Therefore, RAB is 5 ohms plus 9.31 and that gives us 14.31 ohms. So this is how the things go. Is it okay with you, everybody? Anything that you want to ask me, if you have not understood, you can ask me now. Okay, so the approach is important. Which star to approach? So see for a star which has got the same resistors in it. Why the same resistors would help? It would save a lot of time, because if you find out R1, the other two resistors would also be the same because all the resistors in that star is same. Okay, and another mistake the students would do most of the times is this: they'll calculate R1 as this. Okay, this is wrong calculation. Let me tell you, what I'm doing is wrong, but students tend to do this. R1 is what? 6 divided by, or 6 into 6 divided by 6 plus 6 plus 6. Why? There are two equations we are looking at. Which are those two equations? R1 is equal to RA/RB plus RB/RC plus RC/RA divided by RB/RC or something. This type of equations we know. What is another equation? Another equation is RA equal to R1 into R2 divided by R1 plus R2 plus R3. Another equation is of this sort. What people will do, so they'll calculate R1 as this and RA/RB with this equation. So this is wrong. Okay, so this is what you have to be doing. This is what you have to be doing. This is fine. Okay, but when we are calculating a delta, okay, this is the equation. When we are calculating a star, this is the equation. Understand that? Okay, so when we use this equation, we use this equation to obtain what? Delta. This is the equation we use to obtain star. We can write star like this. Is that okay with you? This is wrong. We are trying to obtain a delta out of a star and you're using a wrong equation here. Very commonly made mistake is this by the students if you are not aware of what you're doing. Okay, we are converting a star into delta. So which is the equation? So this is the equation which comes in this form. Is everybody okay? We shall take the same problem and solve it by approaching a different part of the circuit, part of the network rather. Okay, so alternately, let's take the same problem, but let's do it in alternate way. Okay, I'm just telling you how the things differ. Fine. Yeah, alternately, everybody. Because if one problem you understand, solving other problems would not at all be difficult. Okay, so let's take the same circuit alternately. You have taken the same. Okay, no, this is not the circuit. This is already converted circuit. Okay, okay, no problem. Let me take this, the original one. Yeah, let me take this. Yeah. So alternately, we are doing this. Fine. So what is that we're doing alternately? Is this? Everybody copy this circuit again. Everybody copy this circuit again. Don't write this R1, R2, R3. Now we're not approaching this part of this network. We are approaching a different part of the network. Okay. Let me give you that. How we can solve this problem alternately. Not an efficient way, but yeah, you can do it, is what I'm trying to tell you. Yeah, this is the network given. Okay, so what we can do to obtain RAB? Suppose we are not approaching the 666. Understand that? So what we can do is, see here, there is a delta. Can you see, this is a delta. 6618 is a delta. See this 6 ohms, 6 ohms, and 18 is a delta. So you can ask me, delta looks like this, okay, and it's not of that type. No, what is being done here? This is the same point, right? So this is same point. Okay, so what they have done is, instead of writing it this way, so see, this is, suppose this is R1, R2, R3. What they have done is, this is R1, okay, this is R2, and this is R3. What is happening between this end of R1 and R2? They are joined together, right? So this is also a delta, but they have written it through straight lines, vertical lines and horizontal lines. They are not the slant ones. They don't have the slant lines in triangular fashion. Understand? So if you are good enough to make out that, okay, this is also a delta, okay, then you're through. So you need to have that visualization. Okay, 6 6 18, though they don't look like this, they are a delta. It's a delta. 6 6 18 ohms are forming a delta. Understand? So how to obtain a star? See, if there is a delta like this, what do? We mark this. This is how we obtain a star. Yes or not? So what I can do here? See here, I can mark a star like this. Is it okay with you, everybody? Earlier, I took 666 star and converted that into a delta. Now I'm considering this delta, okay, and converting that into a star. Fine. In star, what do we obtain? We obtain what? Yeah. Let me do this. Yeah. What do we do in star? We obtain RA-RB-RC. So we need to obtain RA-RB-RC. Okay. So let me just slightly write here. This is RRA. Let's write this is RB and RC. Now you need to be little careful, because see here, all the resistors are not the same. All the resistors are not the same. So when we are calculating, RA, RB, RC would differ in value. Understand that? Okay. So you need to be little careful regarding that. Fine. So that is what we are doing now. Okay. Yeah. Can we do that by considering the delta? Okay. So let's say consider what is this? This is 6. Okay. This is 18 and this is 6. Okay. So you have this connection. What I'm doing is, what I'm trying to obtain is this dotted lines. Fine. This is 6, 6 and 18. Fine. So this I'll call as RA, RB and RC. Everybody see here very neatly how I am. Let me write it properly. Yeah. Let me call this as RA. Now everybody watch this. This is 6 ohms. Okay. What is RA here? What is RA here? How can I? You need not have to write the equation. Just by seeing this here, if you are writing the RA, we are obtaining the star. We are obtaining a star now. So in star, when you're obtaining a star, how to obtain RA? Okay. So you should see the resistors which are there on both the sides. So it's 18 into 6. Fine. 18 into 6 are there in the numerator. Okay. Divided by all the resistors, 6 plus 6 plus 18. So what would this be? So what is this going to be? This is going to be 3.6. This is going to be 3.6 ohms. Similarly, consider this RB. Okay, if you consider this RB, what would happen? Okay, this is, on both sides it's 18 into 6. Okay, so RB is also 18 into 6 divided by 6 plus 6 plus 18, which is common in all the equations. Fine. What is RB? RB is also 3.6 ohms. What is RC? What is RC? See here, RC is, now it's RC is here. On both sides of RC you have 6 ohms, 6 ohms. So 6 into 6 would come in the numerator, and in the denominator you will have the same. Okay, and this would be 1.2 ohms. Everybody is okay with that? How we obtain RA, RB, RC? See, this is RA, RB, RC. How did we obtain RA, RB, RC? So this is how we obtained it. So therefore the given network would become what? Therefore the given network would become, therefore the network becomes, what we're doing is this. 5 ohms is there anyways. Okay. Now this 6, 18 and 6 would not be there. Fine. So how is it going to look like? I'm just trying to draw it the way the dotted paths are. Okay. So this is how it is going to look like across AB. Now just identify the resistors. This is 5 ohms. Okay. This is RA. RA is 3.6. This is RB. RB is 3.6. RC. RC is 1.2. Another mistake people do is, after they calculate, if you interchange this as 3.6 and this as 1.2, your problem is gone. The wrong. What the resistor you'll get finally is wrong. So the place where you obtain RB is onto the right hand side. So you do this is RB, not this. So that also becomes important. Okay. So this is what we have in place of 6, 18 and 6. Is that understood, everybody? In place of 6, 18 and 6, now we have 3.6, 3.6 and 1.2. This delta is being converted into a star, and the remaining resistors let's write as it is. Okay, what is this? This is 6 ohms. This is 18. Fine. This is 6 ohms. Now see, these three resistors are connected in series. So what is that? 6 plus 18 plus 3.6. Understand? And these two are connected in series. That is 1.2 plus 6. And see, these two resistors are connected in series. That is 5 plus 3.6. See, this is how the things happen to be. Fine. Now just bring them after having the equivalent resistors. Fine. How is that going to look like now? So this is 5 plus 3.6. Fine. Now this is 1.2 plus 6. So this is 3 resistors being in series. Then this is how it looks like. What is this? This is 5 plus 3.6. This is 8.6 ohms. So this is 18 plus 6 is 24. 24 plus 3.6. So it's 27.6 ohms. Okay, and this is 1.2 plus 6 is 7.2 ohms. This is how the things are going to be. So therefore, what is RAB? So RAB is this. This is 8.6. What is this? This is 8.6. Nothing to worry. Okay. What is this? This is 7.2 in parallel with 27.6. What would this be? What would this be? Just check that. Just check that. What would that be? It's 7.2 into 27.6 divided by sum of those two resistors, and that would come as, I'll just give you the final answer. So RAB would be this. We can write your RAB as, okay, it's 8.6 plus the parallel combination of 7.2 and 27.6. So you can do this. How to do this? How to do this? This is 8.6 plus how to find out the parallel combination, 7.2. The product of the two resistors in parallel divided by the sum of those two resistors. Okay. So what is this supposed to be? It is 14.31 ohms, which is the same as we have got in the first method. It's not method. The method is the same. The approach is different. Here, in the second approach, we approached the delta to be converted into a star. In the first approach, we considered the star and converted that into a delta. Is that understood, everybody? Yes?